Section 7.1 has to do with a geometric mean. A geometric mean is a positive square root of the product of two numbers. And the way that it's set up is that these are what we call the extremes and these are the means. So if you say x squared is equal to a times b, then the geometric mean, which is x, is the square root of a times b. So that's always the geometric mean, and this is used in theorems. First, we're just going to practice with finding the geometric mean between two numbers. If I'm looking for the geometric mean between 4 and 9, I set up 4 and 9 in my extreme positions, and I put an x or an unknown in my mean position. So the means are the inside numbers. If you go dot, 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 these are the extremes and these are the means. So then you have x squared is equal to 36, so x would equal 6. So 6 is the geometric mean between 4 and 9. Same thing here. These would go in the extreme locations, and you would put your unknown in the middle or in the mean locations. If you cross product, you get x squared is equal to, and then you're going to multiply your 6 times your 15, so you're going to get a 90, and then you're going to take the square root of 90. Now you could give me a decimal value, or you could break 90 down. Let's see if there's anything. I believe it would just be 9 and 10. So I could say it's the x is equal to 3 on the square root of 10, because the square root of 9 is 3, or I could literally just get what the square root of 90 is, which is 9.49. Either one of those answers are acceptable. 2 over x is equal to x over 50. Again, your numbers go in the extremes, your unknown goes in your means. So I have x squared is equal to 100, and then of course the square root of 100 is 10. So 10 is the geometric mean between 2 and 50. 25 and 7, same way. So x squared is going to equal 175, and then the square root of 175 is equal to 13.23, or you could have broken that down into the square root of 25 times the square root of 7. I hope y'all remember how to do that. So that's 175, which means that's the square root of 25 times the square root of 7, which is 5 on the square root of 7. If you remember right, you're looking for the numbers that you can take a whole square root of. Either one of those answers is acceptable. All right, so this is where some of the theorems come into play using the geometric mean. Not this one, but the next one. If an altitude is drawn from the right angle of a right triangle, then the two triangles formed are similar to the given triangle and each other. So here's my right angle. I draw an altitude, which is from the vertex perpendicular to the opposite side. It separates this into one triangle, two triangles, and they are similar to each other and to the original triangle. So there's your similarity statement. Theorem 7.2 says, if an altitude is drawn from the right angle of a right triangle, okay, here's the right angle of this right triangle, and I'm drawing an altitude, which is from the vertex perpendicular to the opposite side, then the measure of the altitude, okay, is the geometric mean between the two parts of the hypotenuse. So this measure, WY, which is the altitude, is the geometric mean. So I'm putting that in the mean location between the two parts of the hypotenuse. This one's the hypotenuse. The two parts would be XW and WY. z. Okay, and then I could solve, like if this was an unknown, I could multiply through here and solve. So the altitude, if it's drawn from the right angle of a right triangle, it has to follow those specifications. Then the measure of this altitude, or the dotted line, is the geometric mean between this part of the hypotenuse and this part of the hypotenuse. Let's do a problem on that. Okay, so I've got this right triangle. Here's my right angle. I have an altitude drawn from it, so it meets all the specifications. BD is 6, AD is 27. We will call this X. Okay, so CD is what we're trying to find, and we're going to call that X. The altitude, if it's drawn from the right angle of a right triangle, is the geometric mean, so I put that X in the geometric mean location, between the two parts of the hypotenuse. So the one part is 27, the other part is 6. So I've got x squared is equal to 27 times 6, which is 162. And I'm going to take the square root of 162. And I'm going to get 12.73. So that is the measure of the altitude using that theorem. Let's do another one. Okay, again, I've got this large triangle that is a right triangle. Here's my right angle. The altitude is drawn from the right angle of the right triangle. RS is 3, QS is 14, and I'm looking for PS, so I'll call that X. The altitude is the geometric mean, so I'm going to put that in the geometric mean location between the two parts of the hypotenuse. And then I solve for the X. So I have 3 times 14, which is 42. I'm going to take the square root of 42, and it's going to give me X is equal to 6.48. So that is the length of the altitude. All right, then we have another theorem. It says if the altitude is drawn from the right angle of a right triangle, just like before, then the measure of the leg of the is the geometric mean between the whole hypotenuse and the part of the hypotenuse closest to it. So if I want to know the measurement of YZ, YZ is the leg. The legs are what form the right angle. So YZ is the geometric mean, I put it in the geometric mean location, between the whole hypotenuse, which would be XZ, and the part of the hypotenuse closest to that leg. Okay, so WZ. If I did the other side, okay, YX, which is the leg of this right triangle, is the geometric mean, I put it in the geometric mean location, between the whole hypotenuse and the part of the hypotenuse closest to that leg, which is XW. All right, let's do some actual examples here. Okay, so I am looking for C, D, and E. Now, there's a few things that I have to find first. I've got the altitude, so I could do the altitude. I could find C by doing the altitude, or I know that this is a right triangle, so I could find D, because this is going to work in your Pythagorean theorem, which we're going to work a little bit more on in the next section. So 10 squared plus 5 squared is equal to 125. So I'm going to take, so I did 5 squared plus 10 squared is equal to D squared. So this is 125 is equal to D squared. And I can take the square root of 125, and it's going to give me like 11.18. I think what I might do is I might leave it underneath the square root, so I'm then going to say that's 25 times 5, or 5 on the square root of 5. Okay, you can do it that way, or you can get a decimal value for it. All right, so I've got that. I can also know that the altitude drawn from the right angle of a right triangle is the geometric mean, so I put it in the geometric mean location between the two parts of the hypotenuse, which is 5 and c. So this way I can solve for the c. So I have 5c is equal to 100. If I divide by the c, I'm going to get a 20. And so I find out that c is equal to 20. So that's that. Now if I'm looking for e, I know that that leg is the geometric mean, so I'm going to put the e in the geometric mean location between the whole hypotenuse. Well, now I know what this part is, so the whole hypotenuse is 25, which would be from here to here, and the part closest to that leg I'm looking for, which would be 20. So I have e squared, and when I multiply this out, that's going to give me 500. And then I'm going to take the square root of 500, which again, you could either break it down or you can get the actual value for it. Totally up to you. I did it one way here and another way there, but either way is acceptable. All right, let's do this one. I've got the x and the y. The x and the y are the legs of the triangle. Don't have the altitude, but I could find the altitude, but it's not asking me for the altitude here. So this leg is the geometric mean between the whole hypotenuse, which would be 2 plus 4, which is 6, and the part closest to that leg, which would be 4. So I have x squared is equal to 24. So x would equal the square root of 24, which is going to give me 4.90 when it's rounded off. Then I come down here to the y. This leg is the geometric mean between the whole hypotenuse, which is 6, and the part closest to that leg, which would be 2. So I have y squared is equal to 12. So the square root of 12 is equal to 3.46. All right, your homework on this section is page 346, 14 through 34 even.